Welcome to Ask and Learn.
All right, we've got a question here that says that we have the volume between 0 to 30 degrees Celsius of 1 kilograms of water given as the function for V with respect to temperature. That's 999.87 minus 0.0642 6T plus 0.085 043T cubed minus 0.0000679 T cubed. All right, and we want to determine, we want to find the temperature at which water is at its maximum density. First of all, we know that density is the same thing as mass over volume. And we know the mass is already given to us as 1 kilogram, so that we cannot change that. So basically what we're asked to calculate here is what is the temperature at which our volume, will be at its lowest, right? Because the lowest volume would dictate the highest density. All right, we can do that first by taking the derivative of V and calculating critical points when our V derivative is equal to 1. So the derivative of V would be negative 0.6426. Okay, and then we have it being added to 3 times our 0.085, which would be 0.017. Well, I'm sorry, this is a 3 here, a 2 here, not a 3. It's squared here. So we take 2 and we multiply by that value there. All right, we're going to multiply 2 by that. Then you have T, and then you multiply 3 by this value here. It comes out to be negative 0.0002037 T cubed, or T squared, excuse me. Right, all of that is equal to 0. And then if we use the quadratic equation, we can solve for our T to be, or T1 is going to be equal to 3.9665, and our second T would be equal to 79.531. Okay, once again, that's the quadratic formula. Let me just pull it up real quick, just in case any of you have forgotten that. Quadratic formula is the negative b plus the square root of b squared minus 4ac, and then all of that divided by 2a. Okay, and then when you do that and you plug it in, you'll be able to solve for your t's. All right. Once you get your t's, you're going to find the second derivative of v. So the second derivative would be equal to 0.017086 and minus a 2 times this number here, which comes out to 0.000 4074 T. All right, here if we plug in 3.9665 for T, we would get a value that is greater than 0. So we can say that that point, that T1 is a maxima, because we will get 0.01539, and I'll just round it up to here. If you plug in T1 in there, and that is greater than 0, so we can say that's the maxima. And so then if we plug in our T2, we get a negative value. The negative value comes out to be 0.05439, which we know is less than 0, so that will be our minima point. Okay, so we can confirm that the volume is minimized when T is equal to actually, hold on, I'm sorry. This would be your maxima. If it's greater than 0, it is your minima. If it's less than 0, then it's your maxima. Okay, and then we want to choose our minima value because we're looking for the lowest, when the volume is at its lowest, and we know that occurs when T is equal to 3.9665 degrees Celsius. Okay, and when the volume is at its lowest, then our density is at its highest. So we would say the temperature would be 3.9665 for when our volume is at its lowest and our density is at its maximum. All right, well, I hope that clarifies the question. Thank you so much for watching.